Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following equations and rational exponents. In the first example, A, we have g raised to the power of 3 over 4 equals to 8. In order to cancel or to get rid of my 3 over 4 or to change that to the power of 1, I'm going to raise that to the inverse. Note that to find the inverse, if I have 1 over 5, the inverse will be 5 over 1. If I have the inverse of negative x over y, the inverse will be negative y over x. So therefore, using that concept, I'm going to do the same for my g to the power of 3 over 4. The inverse of 3 over 4 to make that 1 will be raising that to 4 over 3. And whatever you do on your left, you do on your right. So I'm going to raise 8 to the power of 4 over 3. Note that 4 over 3 times 3 over 3, that's 1. So therefore I'm left with g equals 8 to the power of 4 over 3. When you have a rational exponent, if I have a to the power of x over y, note that the x is your power and then your y is your root. So another way of writing that in surd form would be the root, the y root of a raised to the power of x. So I'm going to be using that concept to solve such that I have g equals the cube root of 8 raised to the power of 4. So I can start with the cube root, I can start with the power of 4, I'm going to get the same answer. So therefore, starting with the cube root, that is equal to 2, that's cube root of a to the power of 4. Therefore, the value of g equals 2 to the power of 4, 16. Let's look at the second example. In the second example, I have y raised to the power of negative 3 over 2 equals to 8. I'm going to do the same by raising both sides to the inverse of negative 3 over 2. The inverse of negative 3 over 2 will be 2 over negative 3. And whatever you do on your left, you do on your right. So that's going to be 2 over negative 3. Therefore, that cancels out. That's 1. I'm left with y equals the cube root. That's the root of the power of 8 raised to the power of negative 2. What I did was to move my negative to the top. I'm still going to have the same value. So therefore, the cube root of 8, I'm starting with the cube root. Y equals cube root of 8 is 2. So that's 2 raised to the power of negative 2. Note that, laws of exponent, if you have a negative exponent, if I have a to the power of negative y, to make it positive, the negative becomes the fraction bar. So therefore, that's going to be 1 over a to the power of positive y. So therefore, I'm going to do the same here. That's equal to 1 over 2 to the power of 2. Therefore, my y equals 1 over 2 to the power of 2, that's 2 squared, and that is 4. Let's look at the third example. I have w to the power of 4 over 3 equals 16. I'm going to do the same, raise both sides to the inverse of 4 over 3, which is 3 over 4. Whatever you do on your left, you do on your right. This becomes 1, so I have w to the power of 1 equals the fourth root of 16 all cube. I'll start with the fourth root. So I have w equals fourth root of 16, that's 2, then raised to the power of 3. So therefore, my w is equal to 2 cubed, which is 2 times 2 times 2, and that's 8. And looking at the last example, in the fourth example, I have v to the power of negative 4 over 3 equals 2,401. You can pause the video and try to solve that yourself. What you're going to have is raising the left-hand side to the inverse, that's negative 3 over 4. Whatever you do on your left, you do on your right. Therefore, this cancels, this becomes 1. Therefore, your v equals the fourth root of 2,401, all to the power of negative 3. In order to find the fourth root of 2,401, you can check in the comment section on how to use prime factorization to find the roots of numbers. But if I do that, that's going to give me v equals 7 to the power of negative 3. And to make that positive, my v equals 1 over 7 cubed. Therefore, my v equals 1 over 343. Thanks for watching. Bye.